This morning, everyone. As far as our previous class has been considered, we have gone through an sequencing problems related to n jobs realized by single machinery. And in the present day's class, we will be looking at the n different jobs considered in the case of two machines and three different machines. And what are the protocol of different process steps that are being involved for this sequencing kinds of problems. And the primary case, we are all aware of that there is no any processing of this skipping factor from one machinery to the other machinery, or else from one progression to the other progression, as per the law or rule that has been imposed in our OR, that is no passing rule. Based upon that, the sequence need to be followed as per the reports, that is machinery 1 to 2, and next towards the next accessory step. And going on with respect to the basic assumptions, this will be recalling the Can's laws. No machine can process more than one job at a time, because there, there is an tool change involvement existing for the commencement of other operation. And basically, we are programming only one process at a time. Hence, the work part will be operated with respect to one process, and later on will be moving on with respect to another process, depending upon this sequencing agitation. And later on, the processing times on different machines are independent to the order, independent in order for the processing, because of the time fluctuations between one process to the another process is entirely different. Because for example, if you can considering the milling and drilling objects, so initially the milling process need to be performed on such work part, and later on, after progressing it, it has to be transferred to the another machinery for drilling category. And milling involve 5 to 6 months of time period, and later on, for commencement of this, drilling will be involving of 2 to 3 minutes. Hence, there is a main difference between the time factor between one process to another process. And overall, the time involved in moving the job from one machine to another machine, that is very much negligible when compared to the process. Each job, if it is once started on the machine, it is to be performed up to the completion of that particular machine. So there must be an halting time for by the another machinery to access the work part for its process to be began. And these are the assumptions. And even almost all the machineries are different for different kinds of processes, just as we have been discussed. That for milling it is another, drilling it is another, for weaving, boring, threading activity. For the different processes, as per the sequence on that particular work part need to be characterized. It will be continuing so on. In the previous class, we have been saying with respect to processing of the end jobs through one machinery, and even these two machineries. And one of the problem, this was the factory problem we have been solved, that the least time that is being taking place by the processes given in the 6 different processes based upon both the machinery A and the machinery B. The least time that is being obtained will be commenced on the right hand side of the particular process, that is on the B, machine B. As for if the machinery A is considered towards the process, if there is an initial stage onwards, it will be considered least time wait for the machinery A. So this is a strategy that is being followed for filling of this assignment characterization for, and these are acting as a basic steps for the commencement of work in the real industrial field. And even the table of column, what they and what is the ideal time that is being existing for the machinery B after passing the work part from the machinery A, and if there is any delay time towards the machine will be entering into the tabular column, and simultaneously as displayed in here in the machinery A also the vice versa, it will be taking place, that is the difference time or the halting time for entering the input material to the machinery 1 until until this machinery B completes the entire task. So this plays a major important role, and that delay time will be entering in the given table of column as displayed here. And here present delay time we have been seeing before. It is entering into machinery A. It is initially it is starting, and 2 minutes of work has to be progressed from the machinery A. And hence, after 2 minutes it is being entered in here, and it is coming out at 8 minutes of time. And but overall the work time it is 6, and the difference is having of ideal time behavior 2 minutes, because initially machinery A will be in an switch on condition, and until and unless the process that is being commencing in the machinery A, after completing the machinery A, only the work part will be entering into the machinery B. So hence there is a gap of 2 minutes here. So that gap we are entering here. So that is the solving of or identifying this mean variation of entering that particular material to the machinery B. So ideally the machine B will be in working condition for about 2 minutes of time. And meanwhile there is no any delay timings that are being progressed for process number 2, process number 3, 4, and in the case of this 5, it is an existing with a 1 minute of time. And in the process of 6, we are hitting existing on 5 minutes of delay time. So what is the delay time? The question is clearly facing that how much delay time that is being commenced in the case of machinery. So hence this is the delay time. There is 5 plus 1 plus 2. There is 8 minutes of time. And that we will be counting here. And what's the ideal time of the machinery is waiting. So that is 1, that is here, it is displayed 36 minus 30. So if you have been solving based upon the given problem, only the timings with respect to machinery 1 and machinery 2 has been given to us. And based upon that, input time and output time of machinery A, simultaneously the input and output time of machinery B, the mean variation calculation of output towards the machinery A is related directly to the machinery B. And what is the mean variation that is being existing? It have to be entered here, right? And depending upon the tabular column, we will be coming to a conclusion, and that is the solving of work. So this is a problem how the processes need to be commenced by 2 different kinds of machineries will be solved. And later, going on with respect to the 3 different machines. So here it is extending towards the machinery one to another. So that is 1, A, B, and C. And even the sequence need to be maintained, that without having the performance in the machinery B should not be entered, a work part should not be entered from the machinery A to the C. That is the main aspect that need to be commenced here. And hence, we are almost having the different kinds of conditions. And based upon that condition, that is, no process should be crossed out and no passing rule is accepted. That we have been already learned in our regular guidelines or regular steps of solving the problem. But in the case of this condition number 1 and condition 4, the two different conditions, that is minimum of A and minimum of C and minimum of maximum of B. So here the conditions need to be characterized. That is, A should be definitely greater than the B. That is, machinery time, working time should be definitely greater than the B, and simultaneously even C also should not be greater, should be greater than the B machinery. So that we have the length. And for the calculation of the, we have already characterized the processing or mean variations in between these three different machineries, that lead of Z, that is mean variation of job 1, performance of job 1, calculating with respect to A1 plus B1, and simultaneously H for the job 2, that is B plus C. And it high represents the n number of processes that are being existing or commencing by the particular by that machinery. So the machinery name itself, it has been identified here, that machinery A, B, and C. And we'll be having, applying the same procedure for the problem. We'll be looking after one problem. And the machine operator has to perform three operations, that is turning, threading, and knurling on three machineries, that is A, B, and C. And even simultaneously the sequencing order also given us, that is A, B, and C. That is a mean starting from A to the C. Find the optimum sequence and the time in hours or minutes. So we need to find out the optimum sequence that to be followed either as per our problem constraints has been given. It is being satisfying with respect to the three-phase conditions or not. So conditions we have been learned recently. That is, A should be definitely greater than the B. That is nothing but the time factor related towards the machinery A should be greater than the time factors related to the machinery B upon the summation, right? And definitely, second one, it is the time factor related to the C should be definitely greater than the B. So these are the conditions should be satisfied. So here in the tabular column in the given question, there are 6 different kinds of parts should be manufactured as per the following criteria. That is, first one, it is turning operation need to be performed on the lathe machine. Next one, threading need to be characterized. Next one, is knurling has to be performed. And the different timings has been given for each and every kind of process, and depending upon the type of product or type of work piece, and the time will be getting varied. If there is any long lengthy of work part, then obviously time will be getting increased. So that time variations has been given in the process. And for the job 1, the time for turning is 3, threading it is 8, knurling it is 30. Likewise for the 6 different kinds of jobs, the variations with respect to the times has been given. And we'll be identifying with respect to the characterizations or conditions that are being existing with us. First one, minimum job or minimum time that is being taken place in the case of A machinery is equal to, that is 2 from the given question. So we'll be verifying suppose the minimum condition is given. Hence, this fourth job in a given question, that is 2 minutes of time it is being taken place for performing the turning operation. And hence, what is there any another mean, there is minimum value? There is no any minimum value other than this fourth operation. And later to that, next to that, the minimum time that is being performing is in the first operation, that is having 3 minutes of time. So as per the statistics, the minimum time factor of in the A machinery should be greater than the maximum time of the B, right? That is the first condition. So here minimum it is in the case of A 2 minutes of time, and as per the B machinery is considered the maximum time it is, that is 8 minutes of time, and hence as per the conditions in the case of solving the problem is not yet satisfied. First condition. So moving on to the second condition, C, there is minimum time that is being taking place for the job commencement in the machinery C should be greater than the maximum time of the, so that is 8 E8. So either it may be equal or greater. We are having that condition greater than or equal. So hence it is being satisfied. That is 8 is equal to 8, and hence it is being satisfied. So only one conditions are satisfied, and based upon that this problem can be converted into two missions factor. So in the case of three missionaries, because of unsatisfaction with respect to the first condition, it can be solved by comparing the values with respect to missionary B and C, but not with respect to the A, other than this B and C missionaries. And previously already we have been solved the problem, that is two n number of jobs can be performed by two different missionaries, right? So hence, if you have been considered the calculation part as annexed below, that is G for that A plus B, or the time factors that is related towards the machinery A and machinery B, and next towards the machinery B and machinery C. And summation leads towards the additional factors as 3 plus 8, 12 plus 6, like vice versa. And simultaneously for B and C, 8 plus 13, 6 plus 14, likewise. And we are getting the values for these 6 different kinds of jobs. Right? These are the values that are being calculated. And how we have to submit or give the preference as per the operation. We are already having the formula for this, that is examining the column of G and H as per this AB summation, that is G, and B and C machinery summation, that is H we have been considered. So the smallest time of 8 that is related to job 4 on G will be assigning that job number 4 as first in the row that has been given. And next smallest value will be occupied in the next condition related to the G, that is job number 3. And assigning of next 4 and 3, we see that equal minimum values which are having in the case of this G is job number 1. Simultaneously, three different processes has been considered. On the other condition, this related to the processes or jobs that has been considered in the case of this G value, that is summation of A plus B machinery timings, we are being entering from left to right direction. Simultaneously, in the case of this H, that is B plus C constellations of timings, that will be entering from the right towards the left direction. This is the conditions. So after completing this, we need to find that the ideal time that is being existed. So hence, we are having this only two different kinds of processes. That is turning, threading, knurling. Turning is omitted because the condition has been not satisfied. First condition satisfy color, and related to that the preference will be characterized. So order of preference, here we have been obtained the order of preference, that is 4, 3, 1, 6, 2 and 5. So these jobs need to be performed in the following sequence, and if this process has been commenced with respect to this sequencing characterization, then the optimum time or minimum time will be finalized based upon the general format of considerations. That is nothing but ideal time that is being energized by the machinery B and C will be very much greater if this particular sequence has not found out or processed. We'll be looking after furtherly that 0 to 2, that is starting of turning point, that is in the machinery 1, this is machinery 2, and this is machinery. And I am taking here directly the process names, that is turning, and after turning process threading has to be performed, after threading knurling has to be performed, and this is the sequence that I am following. initially I'm starting the work with respect to the job number 4 on fourth work part. So here starting with 0 and after 2 minutes time it is being performed, that is minimum time. And next one it is entering after 2 minutes to the threading, and it is processing for about 6 minutes of time period. After that it will be entering into the knurling process. So here the mean difference that is existing is 2 minutes. 2 minutes the threading process or nothing but machinery B should be in an ideal condition. Until and unless the machinery A completes the work, then only the workload will be entering into the machinery B. And vice versa in the case of this machinery C also. And hence 2 minutes of time delay, or ideally the machine need to be processed in the case of this threading, and simultaneously 8 minutes of time should be in ideal positions regarding this knurling process. And hence these are the delay times that need to be noted on. And later on, after 2 minutes, immediately another work part, that is job number 3, will be entering into the turning. And here there is a process commencement within 5 minutes of time. So 2 plus 5, that is a 7. And next one, it will be entering into the second machinery, processing with respect to the second machinery for about 4 minutes of time. And later on, it is being entering into the regular characteristics. And next, job number 1. And this is the sequence that is being followed. And after completing it, immediately it is being entering towards the next commencement of job. And here, finally, in the sixth condition, we can observe that there is an delay of three different characterizations. That is, in the case of this time factor, we have to consider the case of this time factor. As displayed here, there is 3 minutes of time variation is being considered. Simultaneously, here 11 minutes of delay in the case of this threading process. So now, what is the lapsing time that is being existing? Overall, upon overall strategy, we have been considering 77 minutes of time is being processed for the commencement of this overall process. Three different kinds of process. And individually, if you have been calculated what is the ideal time that is being taken for this turning, so commencing of a total 77, commencing of total 77. Here, addition leads towards this particular process. So 77 is the maximum time that is being taken for commencement of three different processes simultaneously if they have been worked in simultaneous parallelly they have to be worked out. So hence mean value, that is maximum value, minus the mean value, and hence it leads to 35 minutes of time. Ideally the machinery 1, that is A, in the case of turning need to be stay off. And second one, if you have been moved towards the threading process, considering this threading process, here in the tabular column we have been characterized or obtained the minimum values, or these ideal timing values that we will be calculating. And in the process number 1, coming to the jobs here, job number 1, it is fourth job commenced initially, that is occupying with respect to 2 minutes of delay time. And coming to the 4, 5 and 6 jobs as per the serial order, and job related if you have been considered, that is 6, 2 and 5. So here 6, 2 and 5, in the sixth job it has been performed at fourth time, that is 1 minute of delay time, and the fifth one, that is second one, that is 11 minutes of time, and 3 minutes of delay time in the case of fifth job. And in the case of knurling, only having only at initial strategy, that is job number 4, at the time of job number 4. Later on, it is continuously moving on with respect to without any delay conditions. Alright, so here how we have been obtained this mean difference values. So we'll be verifying here once. That is, in the case of second one, in the threading, we have to verify with respect to the threading. So 21 to entering the object or work part is entering at 21 minutes and waiting to or crossing up to 22. So there is any processing commencement for only 1 minute of time. And later on, it is being entering with respect to 20 is commonly back from the turning to the threading. So ideal time that is being existing here for about 11 minutes of time with respect to job number 2 to job number 5. Consider here it is an outlet of 39 and again entering the object, next object at 42 minutes. So 42 minus 39. So 3. So that is the 3 variations. And next here 22 and next 33. The mean variation between these two different process input and output conditions is 11 minutes of time. And here when you have been considered this 20 and 21 and 1 is the difference. So in such a way we will be calculating this ideal time between one process to the other process. Alright, and we'll be summating here in the case of this threading. All the delay timings in almost all the process has been summated leads to 49 minutes. And in the case of this knurling process, we are having only the starting process, that is fourth job, 8 minutes of delay time that we are having. And we have to consider that in the given conditions, initially, two different conditions has been given, that minimum time period that is taken in the case of this machinery A should be definitely greater than or equal to the maximum time of consuming by the machinery B. That is for any kind of process among the given 6 different jobs. But here the criteria haven't satisfied. And let us consider if it is the condition that is satisfied, minimum condition of a job A is having a value of 9 here and maximum of job B is having 8, then the condition will be here in satisfied condition. Then this G of A plus B and H of B plus C will be competing with respect to the highest values. And at that particular time, here the tabular column need to be occupied with respect to the first phase of condition. So first phase of condition ఏంటంటే మనకి ఇక్కడ turning process. Presently first condition in between machinery A and machinery B. So turning process is A, threading process is B. So it haven't satisfied కాలేదు కాబట్టి we have been moved on with respect to two phase kind of solving problem. And then at that particular time, if the condition 1 also satisfied, then we have to take the value of this turning process initially in the left side condition of our solving process, right? In such a way we'll be getting the overall solutions depending upon the given problem. Let me give the one problem for your homework. In the turning condition, the condition need to be satisfied that minimum should be greater than maximum. So at this particular time, consider these values in the given turning A is minimum of 8, starting from 8. So minimum it is 8, and almost all the values should be greater than 8. So here for example it is 9, and hence it is 9, and here it is 8 value. So if these values are greater than the existing maximum value of 8 in the threading process, definitely these also will be getting in addition condition. So consider the process number 1, that is here 9 value, and here in the place of a 5, 8 value. It is can be equal, greater than or equal condition. So 8, and in the case of this fourth process, that is 2, is equal to the 10, and hence then here the values will be getting different. So here it will be coming 9 plus 8, that is 17, and here 8 we have been given 8 plus 4, and here the value will be 12, and here in the place of it is 9, 9 plus 6, that is 15, and hence remaining values are similar. So three different values that we are getting by changing the values. If this first condition is being satisfied, that is minimum condition is definitely greater than or equal to the maximum condition of this B value, then the occupancy towards this process will be progressing from left to the right in condition. Then the similar values, or here the mean condition job preference also will be getting changed with respect to the sequence. That sequence I need from you, right? So obtain that sequence and calculate this entry time in the case of this turning, and entry exit time, and entry time towards the second process, and exit time, and simultaneously towards the entry time in the third machinery, that is knurling machinery, and output time, and generally obtain three different at that particular time. If first condition is also satisfying, we will be getting three different values, that is turning value, threading, and knurling. Already you have been achieved in this condition. So apart with this, additionally you will be get this turning process delay time also. So another one more column will be getting added here. So if it is 0, just as displayed here, simultaneously keep it 0 or else just hide. Alright. So do that as an your homework, and find out the total lapse time, that is calculating. Upon calculation, by incorporation of that, what are the additional numbers that we are being giving. So here 9 we are giving. So 9 in the sense 6 is additional, and next here 8 we are giving, that is 6 is additional again, and here it is 9 we are giving 4. So 6 plus 6, 12 plus 4, that is 16. So 16 minutes of time will be definitely additional with respect to the existing problem. So 77 plus 16. Alright, overall 93. So that 93. Overall, this the turning delay time will be 96 minus 42. Right? Then this value will be getting deferred. I will simultaneously moving towards the second condition, that is threading, second machinery, and that timings are similar. Only we have been changed the values related to turning only. Second mission, third missions will be changed. So only the value of turning will be changed, and hence we will be getting this value turning machinery A value will be getting changed, right? So remaining two values will be in similar condition. So solve this problem, uh, and in the next class we will be moving on with respect to next problem. Thank you.